All right, let's look at another example. So we want to determine if Rolle's theorem applies, and if it does, find the C value or values guaranteed by the theorem. Oh, let's see what we want here. Got to pick some numbers that'll work here. That's the problem.
Mr. Chair, what does it mean for the function to be differentiable or differentiable? Different?
It means that there's no sharp turns in the curve. There's no places where there's a skip or a gap. The real big thing we're looking at, if the curve is already continuous, it doesn't necessarily become differentiable if it does something like that in its graph. That's not really necessarily differentiable. What's happening here is much more difficult to determine. So we're really kind of looking at the structure of the curve. Continuity is the big hurdle to come over. If we've got continuity, unless it does something really strange in here, we pretty much have differentiable. I would not call that a high mark to worry about as differentiability. I would call it a higher mark to worry about continuity.
Are we supposed to figure out the other one?
What other one?
Different.
Differentiable.
Yeah, but are we supposed to like know how to figure that out?
No. All right.
So just to
Question for you. Is this curve continuous on the interval presented?
yeah.
By the way, what happens if it's not continuous outside the intervals presented?
That doesn't matter.
Yeah, we don't care. So it's important to know the question is on the interval presented. Second question is it differentiable on the interval presented? Yes, it is. I don't want you to have that as a big worry. The next question is, does f of negative 1 equal, that's a question, f of 2? We need to determine if that's true or not. That's part of using Rolle's theorem. So figure out what is f of negative 1 and what is f of 2. Determine those y numbers. Maybe I did enough math in my head that maybe it'll work. If not, we're done.
They both equal -4.
Yeah, they both equal negative.
Okay? So we've said this is continuous, this is differentiable on the interval, and it has the same y values at the endpoints. Therefore, Rolle's theorem applies. All right?
So you just plug -1 and 2 back into the...
Back in the original function. I have done nothing with calculus yet. I've done no derivative work yet. We're just determining if it actually applies. In this case, it does apply. Now, I need you to find, listen, in this interval, I need you to find any x value that has a derivative of this function being 0. So how do I do that?
Find the derivative so it equals 0.
That's a great plan. So, being the good calculus students you are, what's the derivative of this function? And I set that equal to 0, right? And so what's my answer?
And we have that equal to both 0 and 2.
Are both of those within the interval? Okay. So, which points make, or which values make Rolle's theorem? Or come out of Rolle's theorem, sorry. Those two?
X equals 0 because you set x equals 0 and then equals 2.
Yeah. By the way, why don't we have one of these numbers at -1? I mean, I got to turn it 2, but I don't have one at -1. Why not? Anybody having to graph this thing? Actually, that's not right either. Sorry, I'm going to draw this correctly.
That would be helpful.
It really would, wouldn't it? There we go.
Are we going to
You don't have to graph it. I just want you to see what the curve is doing. Because we're looking at the interval that starts here and goes to here. You have that point right up there that's happening right in between them. But then this one right here is actually a place where it is a minimum and it turns back up. Even though the interval stops it. The y numbers match up. That's what's happening. Questions about that? Okay. Hopefully this is pretty straightforward. In fact, this should look an awful lot like several of the things that we did last year in math analysis when we were doing polynomial function graphs. We are creeping toward that information that I told you I would tell you this year, last year when I did graphing in my head. We're awful close to it. How I did those things.
So we need to graph it?
No, you don't have to graph it.
Is that negative what, comma -4?
-1, comma -4.
Great, so when we define the coordinates of y
Or what?
like where...
Well, it depends on the instruction. Depends on the instruction. Sometimes you will